Hello guys, in this class, we're going to look at your alkane nomenclature. And in our series of organic chemistry classes, this is our lesson number 22. Oh yes, let's go. So when we talk about alkane nomenclature, in fact, anything nomenclature has to do with naming, right? Sir, I don't know how to name organic compounds. Here is the class. And I want you to pay 100% attention as far as Jamb And Waec is concerned. They are very, very important. First and foremost, I'd like you to note this very quickly with me, right? That alkane nomenclature, see, when we get to alkanes, I'll treat the nomenclatures of alkanes. Alkynes will look at the nomenclature. Every of them are going to be looking at their nomenclature one after the other. But under alkane nomenclature, first and foremost, nomenclatures generally, right? They are divided into three. It's either we have what is called the trivial names of organic compounds, or we're going to be looking at the common names or the IUPAC nomenclature. But for Jamb And Waec, IUPAC nomenclature is where they dwell on. But let me tell you a little about your trivial as well as your common names. First and foremost, when we talk in terms of your trivial names, right? That's why you start hearing things like your CH4. You know your normal CH4 now, the one we call methane. The trivial name for methane is called marsh gas. What is it called? Marsh gas. Either you call it marsh gas or damp fire. That's how we said that your methane, why do we call it marsh gas? Number one, methane is a gas, right? Number two, methane is found in marshy environment or damp environment. That's how we call it your marsh gas or your damp fire. And again, your methanol, your CH3OH, this is the formula for methanol. Methanol is called your wood spirit. So when you hear wood spirit, what are they referring to? Methanol. All of these guys are the trivial names, right? But they don't really use them. You don't need it. Now, here is where you now have another system of naming that we call the common names of compounds, right? These are more like the old names. Now, so what about trivial names? Trivial names are ancient names. Then after trivial names, we came to your common names. Common names, for example, your C2H4, this is your your ethane, right? This is your ethane double bond. Ethane, the common name for it is ethylene. So when you hear ethylene, that's ethane. This guy here, this formula is the formula for your your propane double bond. When you hear propylene is certain as your your propane. But these ones are just their common names. As simple as that, right? And aside the common names, we now have the one we call your IUPAC nomenclature, International Union of Pure and Applied Chemistry. It was introduced, right, in organic chemistry in what year? 19th century. That was when it was introduced, 19th century. And ever since then, it is the IUPAC nomenclature we have been following because it is the standardized format of naming compounds. And you can easily name it easily without stress. Even if you are in the UK, you are in India, you are in Nigeria, you are in Pakistan, you are anywhere around the globe, the name is the same as far as naming of compounds they are concerned. So we're going to dwell on IUPAC name for everything. So when they say alkane nomenclature, it is the IUPAC we're referring to. Let's go together, guys. Hold on a bit. The complete series of classes, right, as far as your syllabus is concerned regarding your Jamb And Waec, everything has been covered in details for you in the LearnLift app. And guess what? The sweet part is that you have access to your CBT, right? You have access to your video lessons. You have access to your notes. You have access to your past questions. Everything from the beginning to the end is directly in the LearnLift app for you. So all you have to do is just mark down to Play Store or App Store and download the LearnLift app where you follow all your classes from the beginning to the end. A quick one before we move. Let's get back to class. Enjoy. First and foremost, right, there are a total of 7 prefixes that we use in naming alkanes. How many? 7 altogether. But for this level, Jamb And Waec, we have to know 4. How many? 4. I will dwell on that 4 alone. The first is the one we call your normal alkanes. What do I call it? Normal alkanes. Normal alkanes are also called your N-alkanes. Bro, relax. You are going to learn it. N-alkanes. Follow with me. Number 2 is called your zigzag representation. What is it called? Zigzag representation. Zigzag. Some people will be complaining, I went for Pusitieni, they now gave me zigzag representation. I did not know what to do. Learn it down now. Number 3 is the one we call your isoalkanes. That's where your isomerism stem out from, right? Isomers of alkanes. And then number 4 is the one we call your cycloalkanes. What is it called? Cycloalkanes. So we have N-alkanes or normal alkanes. We have your zigzag representation. We have your isoalkanes. And we have your cycloalkanes. You must note them well, right? Yeah, let's go. Let's start with the first. And that is your normal alkane. So all through this class, we are going to learn normal alkane alone because that's where we have the naming. First and foremost, you must note this, that it is formed when all the carbon atoms, they form either a continuous chain or they form an unbranched, right? Continuous unbranched chains. Continuous and unbranched chains. That unbranched chains are the linear chains. This is what we refer to as your normal alkanes. I will show you. A good example is what we have here very fast. If you are to name this compound, of course, you don't need to stress. That's your methane. But you can choose to just call it. Anyway, you may choose to let's just say methane. Let's not stress first. Let's start from there, methane. What about this compound if you are to name it? Simple. In naming this compound, you call it your what? Look at it. How many carbon is there? 3 carbon. Carbon 1, carbon 2, carbon 3. So we can call that your what? Your propane. So this guy is called your propane, right? But now look at this very fast. How do we name this compound? Of course, you see the one we call propane just now, you can choose to call it N-propane. N-propane is telling you that it's normal propane, but whether you put the N here or you don't put it there does not matter. But this guy, you must put it here. In this compound here, this is 1, 2, 3, 4, 5, 6, 7. 7 carbon. Straight possible continuous chain. What do we call this? 7 is hept. So this guy is called your what? Your N-heptane. What is it called? N-heptane. That's the name of this compound. It's period. No stress. Okay. What if I now have my 1, 2, 3, 4, probably 5, right? 6, 7. What's the name of this compound? Please, you know, every other side here like this, you are going to have hydrogen. I don't need to draw the hydrogen. Man, no stress. Man, just the move. Every other area here is going to have hydrogen. So if I'm to name this compound, right, what do I do? This is N-heptane, normal heptane, because the longest continuous chain that we have there, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. It is continuous, whether it is straight or a call branch small. But it is continuous, right? So we can still call this your what? Your normal heptane. You are correct. Don't worry. As we move, you are going to understand some more. Now, another one is what we have here. How do we name this compound? Very, very easy. Simple thing. Come with me. This is carbon 1. You can start counting from any side, whether from the up or from down, anywhere. Carbon 1. Here is carbon 2. Carbon 3. Here is carbon 4. Carbon 5. Carbon 6. Carbon 7. Carbon 8. Carbon 9. 9 is none, right? None. That is your N-nonane. N what? Nonane is the name of this compound. Very easy and direct. Normal nonane. If you get that very quickly with me. The next thing we're going to learn here is the rules for naming alkanes. What are the various rules that we must apply if we must name alkanes? Well, let's go. In the rules for naming alkane, you must note this, that these rules, they govern continuous. Whether they are continuous chain, it governs it. Whether they are non-continuous chain, it is also valid. Whether they are branch chain, correct. Whether they are unbranched chain, also very, very what? Correct. Anything alkanes at all these rules apply. And how many rules altogether? I'm going to give you a total of 8 rules in naming alkanes. 8 of them. Let them be part of you. Are you getting me now? Bind them around you. Let them be integral part of you. Rule number 1 for naming alkanes. What is it? The general name for paraffin. We said that alkanes or paraffins. The general name for alkanes, they are what? For your paraffins, they are your what? Alkanes, right? Or your saturated aliphatic hydrocarbons. You know your saturated aliphatic hydrocarbons are the alkanes. Your paraffins are the alkanes. So this rule holds for all of them. Rule 2, very quickly. Don't forget this very fast. Here is where the rule begins from more. In rule 2 here, for branched chain hydrocarbons, what did I call it? Branched chain hydrocarbons. What you do first is to determine the longest continuous chain. What do you determine? The longest continuous chain of carbon in the molecule of that compound that you have been given. Just determine the longest possible continuous chain. And don't forget that longest possible continuous chain become the parent compound. Either you call it the parent compound or the root compound. The longest possible continuous chain. What do you call it? The parent compound or the root compound. Okay, let's say we have something of this nature. How do we go about this? Very simple, easy and direct. What you do is this. We say go for the longest possible continuous chain. Count with me. You may choose to say, okay, here is carbon 1, here is carbon 2, here is carbon 3, here is carbon 4, here is carbon 5, here is carbon 6. Is that the longest? Another person may say, okay, oh, here is carbon 1, here is carbon 2, here is carbon 3, here is carbon 4, here is carbon 5, here is carbon 6, here is carbon 7. Now, let me ask you, 6 and 7, what's the longest? 7 is the longest. So you see, the longest now that is possible is this guy like this, right? Whether you are numbering it from the left or the right, it doesn't matter yet. First, as you move, you are going to see it. I'll tell you the exact one you are going to follow. So when it comes to creating an account, right? This is the interface of the app that you can see. You can see create account and you can also see login. Now, what you do is this. As a new user, you don't have an account yet, so you don't need to go and log in. You go and create an account as a new user. Click on that create account button. Once you click on it, the next thing is put your phone number. Place in your phone number. You can see +234. Then put your phone number, whatever your phone number is. If you don't have phone, you can use your mommy's phone number and put it there, right? Or your daddy's phone number. Use it, and then you can proceed and create the account. So let's go. So once you create the account, you are putting your phone number. What happened? Put your name, your correct phone number, please. Put your name. If your name is John, what do you fill in there? John. And then your last name, Frank. Fill in John Frank. And what's your email address? Okay, if your email address is johnfrank3@gmail.com, you fill it there. And then your password, very important. You create your own password, 6 digits. You can use your phone number, the first 6 digits of your phone number, or the last 6 digits of your phone number. Or you can, okay, since your name is John Frank, you can say, okay, my password name is John, right? John 123. And then you go and repeat the same thing, confirm password. What will you type there? Your John what? 123. You can decide to view it to yes or and then see whether you are doing the same thing, whether what you are doing is correct, right? All you have to do is just click the I button there and then you view it. And then come to select education. You are preparing for Jamb or Waec. In select education, there are 4 plans there. University, that's for people that are in university. Probably 100 level, 200 level, right? Yes, their classes are also there. Secondary, for those in secondary school, primary. But for Jamb and Waec, click Waec Jamb Utme, right? As the select education. Select level. You are not preparing for Utme, you are preparing for Jamb and Waec, right? Okay, click on the Jamb and Waec. And then create your account. 2 seconds. Plus, you don't enter. It will load and then it will open for you. And it will tell you, welcome, John, right? Your classes are now ready. What do? Start learning. Locate the longest possible continuous chain. That's rule 2. Everybody wants to go. What's the rule that you must know here? Locate the longest possible continuous chain. Whether it is straight chain or branch, the one that is the longest, that's the one that consigns us, and that's 7 there. Okay, let's go. Rule number 3, very fast. Rule 3. What do you do here? The carbon atoms in the continuous chain are then numbered. How? Beginning at the end, nearest to the branching. Let me simplify what this is trying to say. Start your numbering, right, by giving the least possible value to the substituent. Come, let me show you. Look at this very fast. From this here, give me the numbering. The numbering is here is your 1, carbon 1. Here's your carbon 2, carbon 3. So I thought you number it from down, whether down or up, anyone, doesn't matter. Here's your carbon 4, here's your carbon 5, here's your carbon 6, here's your carbon 7. You see, after you have picked out the longest possible continuous chain, right? Don't cram, just know these rules. The next thing to do is this very quickly. Where do I all these other guys here, what do we call them? They are called attaché. What are they called? Attaché. What do I call them? They are called attaché. Either you call them attaché or you call them substituents. Substituent groups. That's what you call them. Either you call them what? Attaché or what? Substituent groups. What do I do? You number in such a way that you give the least possible value to the substituent group. Say it with me. Number in such a way that you give the least possible value to the substituent group. Everybody cannot you. Give me again. Number in such a way that you give the least possible value to the what? Substituent group. Now, look at it. If we are numbering the way we just numbered like this, at what carbon will we get to the first substituent? Carbon 1, no substituent. Been looking at it very well. Been looking at it. Carbon 1, no substituent. Carbon 2, from my numbering, the ones with yellow. Carbon 1, no substituent. Carbon 2, no substituent. Carbon 3, no substituent. Carbon 4, he said we have our first substituent. Is that how we are going to number? If you are numbering like that, now look at it. We may choose to number the other way around. Follow me. Numbering the other way around will mean that here is carbon 1, here is carbon 2, carbon 3, we are in our first substituent already. But if you are numbering like this, carbon 4 before you get to the first substituent. Now, what is this rule telling us? The carbon atom in the continuous chain, they are numbered beginning at the end nearest the branching. In other words, give the least possible value to the substituent. And what's the least possible value we are going to give? Is it 3 or 4? Of course, it will be 3. So where do we start numbering from? If you number like this, you are wrong. How do you number? Number it this way. Period. So what is it going to be? 1, 2, 3, 4, 5, 6, 7. So the first substituent is in carbon 3. The second substituent is in carbon what? 4. That's all. Don't worry, you will let this thing very easy. The next rule now is rule number 4. In your rule number 4, what do? Each substituent is given two things, a name and a number. When they gave birth to you, what did they do? The next thing was that they started thinking of the name they are going to give birth to them. They are going to name you. In fact, some of you, they've even named you already before they gave birth to you. Right ahead. Or maybe probably your parents ran out of names. Then they now just looked at you. Junior. They say your name is Junior. Let's go. Each substituent is given a name and a number. Should in case your name is Junior and they play. And don't forget this very quickly, that the name of the substituent corresponds to the alkane with the same number of carbon atoms, except that the ending will now change to "-ile". Don't worry, don't stress. That one is a simple thing. I will explain it for you. The N, like in your alkanes, they have changed it to "-ile". Look at it. Look at this very fast. Where did we agree we are going to number from? You are going to start numbering from here. Here's your carbon 1, here's your carbon 2, carbon 3, carbon 4, carbon 5, carbon 6, carbon 7. You know, each substituent is given a name and a number. This guy here, the number is 3. The number here is what? 4. Now, that's the number. What about the name? The substituent in carbon 3, if you watch, that is methyl. What is it? Methyl. CH3 is methyl. Methyl, right, is a methane that has lost one hydrogen, because alkyl, they are alkanes that have lost one hydrogen. Now, what about the substituent in carbon 4? That substituent in carbon 4, that is your CH2, CH3. She knows that it's supposed to be CH3 to be ethane. Now, what is the name? It is called your ethyl. Ethyl is the name of the compound. Simple. Don't forget that substituent in the third carbon has a name and a number now, right? Oh, yes. So what is it? It is the number we come first. That's 3 what? That's 3-methyl, right? Beautiful. That's what we call this substituent, 3-methyl. What about this guy now? That's 4. 4 what? Will it be methyl or ethyl? 4-ethyl. Sharp. That's the name. 3-methyl, 4-ethyl. That's their names, respectively. If you watch, I've not named the entire full compound, because when I'm done with you in this class, in fact, you can even go and open chemist and start selling drugs. No tossing and me said you. Now, the next rule is rule number 5. In rule 5, what happened? In the presence of 2 or more substituents, what happened there? the numbering of the longest continuous chain starts from the end that will give the substituent the lowest possible numbers. Don't worry, I will explain. The lower number being given to the substituent nearest to the end of the chain. Don't stress. Come, let me interpret. Look at this very fast. All right. We have already agreed that this guy is substituent. This guy is substituent. Which one are we going to give the least value to? Carbon. Of course, we have agreed first. Where do we start numbering from? Is it from here or from here? Of course, it's from here, right? That's what we dwell on. Here is your 1, here is your 2, here is your 3, here is your 4, here is your 5, here is your 6, here is your 7. Okay, that 7 now, what's the parent's name? Hept is the parent's name. At carbon 3, what do we have there? Substituent called your what? Your methyl. At carbon 4, substituent called your what? Your ethyl. So that's what we have there. Now, the quick question is this. If you are to name this compound, how do you name it? Are you good to go? Are you good to go? You will name substituent first before the parent compound. Name the substituent first. But please learn this. So if you are naming substituent, we'll name them alphabetically. Is it ethyl? E that will come first, or it is M that will come first alphabetically? E will come before what? M. Don't worry, we'll get to the rule shortly. So what's the name of this compound? Carbon 4 is one that is the ethyl. So it will be 4-ethyl. That's the name, 4-ethyl, right? Then carbon 3 as methyl, 3-methyl, 4-ethyl, 3-methyl. What's the parent name now? Hept. Heptane. That's the name of the compound. 4-ethyl, 3-methyl, what? Heptane. Don't worry, you learn all of it. Rule 6. What happened in rule 6 very quickly? In rule 6, if the same substituent occur more than once, the same substituent is coming more than once, the number of the carbon atom to which each is attached must be given. And you must notice that the number of identical groups, right, is indicated by the Greek prefixes. That's why we now start having things like your di, your tri, your tetra. What they mean is this. Look at this compound. Name it for me. In naming this compound, first and foremost, what happens? Of course, you know where to start counting from, right? Ahead. This is what I've been dealing with since 1, 2, 3, right? 4, 5, 6, 7. Of course, this is a very simple one. It's not appearing multiple times that we wanted. This is 3-methyl and then 4-ethyl. You must name them alphabetically. So what is the name there? The name is your what? Your 4-ethyl, right? Let's write it down. 4-ethyl. Then what? 3-methyl. 3-methyl what? Heptane. That's the name of the compound. Simple. Okay, look at this beautiful guy now, and we have to name this. How do we name this compound? Very, very fast. Come, locate the longest possible continuous chain. That's the rule 1. Tell me which one will be the longest. We are come. In locating the longest, you know some people will go and make mistake in the hall. They will say 1, 2, 3, 4, 5. Substituent. Rubbish, you are wrong. How do we name it correctly? Locate the longest. Here is 1, here is 2, here is 3, here is 4, here is 5, here is 6, here is 7. In fact, here is 8, here is 9. Because if I had continued from 7 and then I said here is 8, I would have missed 9. Right? What is the longest there? The longest is the one that has what? 9. So if the longest has 9, every other will now be what? Substituents. Come with me, you come ahead. Now, if you watch, since I've located the longest, others are substituents. So this guy is substituent. That means at carbon 7, there is substituent here. At carbon 4, there is substituent here. At carbon 2, there is what? Substituent here. How many substituents are together? There are 3 substituents there. Okay, sir, what if I start counting from here? Here is my 1, here is my 2, here is my 3. Come, let me show you what will happen there. Don't forget that if you count it this way, we have gone originally, the first way we have gone. At carbon 2, that's where we have our first substituent. At carbon 2, this carbon 2 as a substituent, right? Because you must give the least possible value to the substituent. But let's say that position 9 is position 1. What will happen there? Let's see. If that occur, that means here will be 1 at carbon 1, no substituents. Carbon 2, no substituents. Carbon 3, before we get to our first substituent. It's not true. We can't do that. Carbon 1, no substituent. Carbon 2, we are already having substituents. Yes, that's what we're going to do. Do you understand it now? Yeah, let's go. So it's going to give us overall, here is your 1, here is your 2, here is your 3, here is your 4, here is your 5, here is your 6, here is your 7, here is your 8, here is your 9 substituents, right? substituent, substituent. So what's the name of this? If you watch, at carbon 2, there is methyl. At carbon 4, there is methyl. At carbon 7, there is methyl. Methyl, that is the substituent, is how many times there? 3 times, right? That means 2, 4, 7. 2, 4, 7, how many are there together? That's 3 methyl. That will form trimethyl. What will it form? Trimethyl. Because methyl is occurring how many times? 3 times. 2, 4, 7 trimethyl. What's the parent name? Parent name will now be what? That's 9 carbon. That's what? Nonane. Nonane become the answer. Nonane. That's the correct answer. And you are out of there, no stress. Do you understand this very fast? If you are sure you really do understand it, what is the name? We said the name is your what? Your 2, 4, 7 what? Trimethyl nonane. That's all you are out of there. Does it make sense? And if you watch, there is something lovely I'm doing. Between number and number, like 2, 4, 7. I did not just write 2, 4, 7 like that. No. 2, 4, 7. Between number and number, there is comma. But between number and alphabet, right, there is hyphen. So 7 try. Sure you see. Between number and alphabet, what will there be? There will be what? Hyphen. Between number and number, there will be comma. But between number and alphabet, there will be what? Hyphen. Don't forget that's a very cardinal rule. Look at the next rule, rule 7. I'm giving you 8 rules altogether. In rule 7, in case the substituents are different alkyl group, what do? Name them in alphabetical order. Name them in alphabetical order before the parent name will come. So the parent name will always come last. Okay, look at this very fast. Name this for me. Locate the longest possible continuous chain. What is the longest there? Here is going to give us 1, 2, 3, 4, 5, 6, 7. Is that the longest? Okay, let me still continue. 1, 2, 3, 4, 5, 6, 7. Better. Instead of me to go this way like this, right? I better proceed this way. Now, the one that we're not going to go with, we're not going with this and this. Do you understand? So we can choose to go this way like this. That's 7. So if I go that way and it is 7, now look at this. At carbon 2, carbon 1, no substituents. Carbon 2, we already have what? Substituent. Yeah. Lovely. Now, if carbon 2 has substituent, when do we now add the next substituent? Carbon 3, no substituent. Carbon 4, no substituent. The next substituent is in now carbon what? 5. So carbon 2 first, carbon 5 next. Let's see if we are deciding to count the other way around. If we are counting the other way around, see, it's still the same. Instead of if you call here carbon 1, you may choose to call here 1. If you choose to come and call here 1, anyway, you like call 1, you are correct. Let's say you are calling here 1. Here is your 2. Let me take out this. Here is your 2. Here is your 3. Here is your 4. Here is your 5. Here is your 6. Here is your 7. Now, what happened? If I count it this way, 1 to 7, you see carbon 2. There is what? Substituent. Lovely. The next substituent is directly in carbon 3. So which one are we going to go with? We are going to go with our numbering like this. Simple. Carbon 2, substituent. Carbon 3, we have another. So you must always pay attention to those things, right? Is it taking time before we get to substituent, or we should quick get to substituent? That's the rule. Are you getting it now? So that's all. So want to go, let's number and name. Here is your 1, here is your 2, here is your 3, here is your 4, here is your 5, here is your 6. Now, at carbon 2, there is methyl. At carbon 6, there is methyl. But at carbon 3, now there is what? Ethyl. And you must name them alphabetically. Is it methyl first or ethyl first? Ethyl first. So what's the name? The name of this compound is nothing but your what? Your 3-ethyl, right? 3-ethyl. What do we now have? Carbon 2 is methyl, carbon 6 is methyl. 3-ethyl, 2,6-dimethyl. Di. That means methyl is coming how many times? Twice. That will be dimethyl, right? What's the parent name, the longest carbon? Is it 6 or 7? 7 is the longest. That 7 will now be what? Heptane. So this is the name of the compound. Easy and direct. Do you understand? If you get this, can we now proceed? Okay. What about if, sir, I decide to write mine like this as 2,6-dimethyl? I told you that methyl and ethyl, which one will come first? Alphabetically, methyl, that's your ethyl will come first before what? Methyl. So this guy is what? Wrong. This is the one that is what? Correct. Does it make sense? If you get that very fast, name this compound for me very quickly. Now that you have created your account, right, for you to start learning, what do you do? Okay, you can see that your use of English is there, mathematics is there, biology is there, physics is there, chemistry is there. Your classes are organized, they are all there for you, right? What do you do? Okay, I want to start learning biology. So click on the biology, immediately you click on it, living organisms, that's chapter 1, right? Oh yes, that's strictly to your JAMB syllabus. And what happened? Let's say, for example, you want to watch your class on cell and probably cell structure, right? What happens is that you click on it. Immediately you click on it, you see all the classes will display history of cell, types of cells, cell organelles, and all of that. Okay, sir, I want to watch history of cells. You click on the history of cell immediately. Your class will start playing for you. It's easy and not. It will start playing for you easy and direct. And what happened? You can even choose to make it full screen, right? Make it full screen. What happens? You are started learning and you are enjoying your classes. In fact, you may choose to say, okay, I want to download my classes. In fact, you can fast forward, you can take it backwards, you can pause, you can rewind, anyone you want to do. You can even say, oh, sir, I want to download my classes, right? Probably you use NightSub just to click on download buttons. When you click on download button, you see the download. Before you know what will happen, the download will start loading. As it start loading, you can see it is moving. And then it's enter your phone. Are you getting it now? You can now go and start watching your downloaded classes. You can download as many classes as possible as you want to download. Now, you can even choose to say, okay, sir, that's the notes underneath it. It's the same thing for everything. I want to download my notes. All you have to do is click on the download for your notes. Before you know what is happening, it has entered your phone. You may choose to come to the notes, right? Under the characteristics of living things, let me open the notes and read the notes and go through the past questions. So you see, well organized and structured notes, direct to the points, focusing on your syllabus for you. There are past questions for you in abundance. You see, you have your past questions here. You can choose to say, okay, I want to zoom it in, right? And then the same thing for all subjects. And you are following. The answers are there. Number 1 answer is B. Why is the answer B? It is explained for you in details. Every singular thing. And then you are following your classes. You are done with that. You come to the next. You see your notes. Everything structured and organized to the core. In fact, at the end of the day, there is a blow kiss for you. You have done well. Get out. You too much. Everything is structured and organized for you in the app, right? And you can now choose to say, okay, sir, what about chemistry classes or physics classes? You can do same. Use of English, all of them, they are there. When you click on your chemistry classes, what happens? Separation of mixtures and purification. All of them are in line with your JAMB syllabus. Chemical combination, right? It just goes straight. You see, chapter 1 alone has 39 videos. 39, you sit yourself down, and you start learning. And you are following all of them one after the order. Does it make sense? Are you with me? When you want to access your download classes, all you have to do is just scroll down right on your home interface. Go to your access your download classes. Start now. You start. You see them, right? In fact, you may even choose to go and practice CBT, right, or past question. Let's say, for example, I go to my CBT, the one that has to do with my my biology. Then I want to take all the questions on that cell, probably your Waec cell or the JAMB question on it, right? Just to click on it. So you see, all the questions are there. There are 40 questions there for you already. All of them on that cell. What happened? Which of the following cell inclusion can destroy other cell organelles? Probably you now say, oh, some answer is lysosomal. You choose it, you go to next like that. At the end of the day, you see your answer, see your corrections. All of these things are in the LearnLift app directly for you. Are you with me? So as far as your JAMB 2025 is concerned, my dear, you don't have an excuse whatsoever to have anything less than 300. Are you with me? All your classes are available for you. All you have to do, start learning now.
Download the LearnLift app now.
How do we name it? Name it. It's very simple. So only you reason, where are we going to start numbering from? From here or from here? Count. Tell me, which of them are we going to start numbering from? Are we going to start numbering from A or we're going to start numbering from B? Which of them are we going to apply? Correct. We're going to start from what? B, not A. And you know the reason why, right? Because of substituents. Good. So in achieving that, what is it going to give us? Here is your carbon 1, here is your carbon 2, here is your carbon 3, here is your carbon 4, here is your carbon 5, 6, 7, 8, 9, 10. 10 is the king, right? And then here is your what? Ethyl. Here is your what? Methyl. Here is your what? Your propyl. So if I have methyl, ethyl, propyl, which one will come first? Ethyl is 1. Alphabetically, A, B, C, D, E, F, G, H, I, J, K, L, M. This is 2, and then this is what? 3, alphabetically, right? So what's the name now? The numbers will now start. The first one that will come is ethyl. Ethyl is in which carbon? Ethyl is in carbon 3. That will give you 3 ethyl, right? 3 ethyl. Then methyl will follow. How many methyl? 4 methyl. 3 ethyl, 4 methyl. 6 is propyl. Then 6 propyl. Then the parent name has 10 carbon. What will it be? Decane. Decane, that's it. So once you go, what's the name? The name is your what? Your 3 ethyl, correct. 4 methyl, correct. 6 propyl, decane. Simple, that's the name. You are out of there. Does it make sense? If you are very sure you understand that very quickly with me, look at rule 8, the last but not the least. In rule 8, what do we do there? Between numbers, alaye abeg, use what? Comma. So if I have 1, 1, 2, 4, probably tetramethyl. So between number and number, what will be there? Comma will be there. And again, between number and alphabet, what did I say will be there? Hyphen will be there. If you see 4 to tetra, that one will not be there. Hyphen is what we are going to have there. And last but not the least, between the last alkyl and the parent alkane, there is no space. Between the last alkyl and the parent name, there is no space. A good example is this. Come with me. Between number and number, what do you have there? Comma. But between number and alphabet, what do you have there? Hyphen. 2, 6, 2,6 hyphen dimethyl. So what is the last alkyl here? Ethyl is the last, and then heptane is the parent name. So between the last alkyl and the parent name, is there space there? There is no space. That's the rule. Another one very fast is what we have here. Your 3 ethyl, number and alphabet, hyphen, right? Number and alphabet, hyphen, number, alphabet, hyphen. Then pull them, propyl decane. Simple things there. No space. If you get that very fast with me, I'd like you to do this for me very quickly. Draw the structure for 2,2-dimethyl propane. How do we draw the structure? For your propane is 3 carbons. 1, 2, 3, right? Yes. They say 2,2-dimethyl. At carbon 2, there is methyl, CH3. At carbon 2 here, there is still what? Methyl, CH3. Right? So now balance this. Here will be nothing but like this, hydrogen, hydrogen, hydrogen. Here like this, balance it. What do you have there? Hydrogen, hydrogen, hydrogen. This is methyl, methyl, carbon 1, carbon 2. 2,2-dimethyl. Then the parent name is what? 3. Propane. As simple as that. That's how you're out of there. Now look at this very fast. Draw the structure for 2,2,3-trimethylbutane. How do we draw it? The parent name is butane. If you have to draw, write the parent name first. C to C to C to C. Parent. But out. 2,2,3-trimethyl. That means on carbon 2. Let's say yes, carbon 1. Yes, carbon 2. On carbon 2, there is methyl, CH3. On carbon 2, there's another methyl. That's why it is what? Your 2,2. Then 3-tri. On carbon 3, now this is carbon 3. There is another what? Methyl, right? Yes. And once I've done this, man, I'm good to go. This is the 4th carbon here. Just go and fill hydrogen everywhere that is left. Once you have done that, you are very, very, very correct. So this is the structure of the compound called 2,2,3-trimethylbutane. That's all. Now, look at Jamb 1981 question 5. Look at the beautiful question that Jamb brought. If you fail anyone, I will not be happy with you. Look at the question that Jamb brought. They said the IUPAC name of the compound is, let's be naming it before we see the options. What do we do here? Here is your carbon 1. Let's go here carbon 1. Here's your carbon 2, carbon 3, carbon 4. So 4 carbons. How many is that? That's butane. So this is your what? Your methyl. Sure, you see methyl. That methyl is on what carbon? 2. It's on carbon 2. So what's the name of the compound? 2-methyl butane. That's the answer. 2-methylbutane, that's the answer. So what 1-methyl pentane, never. Butane it is. Your 3-methyl, no. Option C says 2-methyl butane. Sure, you see, that's the correct answer. Option D says 1-dimethyl, that's not the answer. What is the answer? 2-methyl butane. Option what? C. You are out of there. The same question was now reorganized and retwickled in another format in 1984. Question 49. The IUPAC name of the compound is, what's the IUPAC name? Give the least possible value to the word substituent. This here is the substituent, right? Yes. So how do we number it? Start from here. If you start from the other way, you'll be wrong. Here will be 1, here will be what? 2, here is 3, and here is what? 4. So it is still butane. What's the name? But 2-methylbutane. What is the answer? 2-methylbutane. Option A says isopropyl ethane. No, it's not true. Option B says acetylene. Option C says 2-methylbutane. Correct. Option D says 4-methyl. What is the answer? 2-methyl what? Butane. Option C. You are out of there. Does it make sense? Beautiful. Now the next very quickly is question 5. How do we name this compound here very quickly? In naming this compound, see that it's very simple. We have flow with me. Here is going to give, let me draw the structure so that you see it to a CH3, right, to CH. Here is to your C, to H, CH2. Here is to your what? Your Cl. Here is to your what? Your CH3. Now let's count. Here is your 1, right? Here is your 2. If I go like this, I'll be wrong. No. Better let me come here as 3. I will explain. Here become attaché. That's on carbon 2 now. There is methyl. You know, this 3 is already out. That methyl is attached to carbon 2 now ahead. This carbon 3 now has chloro. So that chloro is another attaché. Methyl is another attaché. So how do I name it? On carbon 3, what do we have there? Chloro. But since chloro is an attaché, why don't I just better start my counting from that carbon that carry chloro as carbon 1. That's what you are going to do. So in the actual way now, here will be carbon 1, here is carbon 2, and here will become our what? Carbon 3. Very simple. So what is the name? The name of this is 1-chloro, because on carbon 1, that's why we have chloro. That's 1-chloro. 1-chloro what? Then 2 is methyl. 1-chloro, 2-methyl, 2-methyl. Then propane is the parent name. That's all. 1-chloro, 2-methylpropane. Let's check the one that is the correct one there. In looking for that is the correct one, now the compound below is known as, what is it called? 1-chloro, 2-methylbutane. Correct. Is it butane or propane? Of course, it is not butane, it is what? Propane. So that cannot be the answer. Option B says 1-chloro, 2-methylpropane. Correct. That's it now. It is not butane but propane. Option C, 2-chloro, no. Option D, 1-chloro, 2-2, no. What is the answer? 1-chloro, 2-methyl what? Propane. Option what? B is the answer. You're out of there. Look at the next question here. Question 6 very quickly. And the question says the IUPAC nomenclature of the compound below is, what's the IUPAC name of this compound? Come with me. Here is your carbon 1, here is your carbon 2, here is your carbon 3, here is your carbon 4, here is your carbon 5, here is your carbon 6. At carbon 2, attaché. At carbon 4, attaché. If you start numbering like this, you are wrong. Go try it yourself now and see. So what's the name of this compound? It's going to give us nothing but your 2,4-dimethyl. The name is your 2, 4, then dimethyl. The parent name is what? Hexane. That's the name of the compound. Option A says dimethylhexane. B says 3,5-dimethylpentane. C says 1,1-dimethyl. Option D says your 2,4-dimethylhexane. What's the answer? Option D is the correct answer. Show you see that it's very simple. Answer this last question for me before you go to my notes. The question says the IUPAC name of the organic compound with the structure below is, what's the IUPAC name? Let's go. The IUPAC name, fast. Here we give you carbon 1, here's your carbon 2, right? Okay, here's your carbon 3, here's your carbon 4, here's your carbon 5, here's your carbon 6. Sir, what if I decide to name it like this? If you name it like that, 1, 2, carbon 2, you are going to have attaché. But if that carbon 2 has attaché, the next attaché will be 2, 3, 4 before you have another attaché. But if you are naming it this way, that is numbered already. 1, 2, 3, 4, 5, 6. What happened? Carbon 2, there is attaché. Carbon 3, there is attaché. So what happened is that carbon 2, there is attaché. 3, there is what? Attaché. They are very close. And then carbon 5, we also have attaché. So how do we name it? Of course, your ethyl is attaché. Methyl is attaché. We are going to give priority to what? Ethyl first. So what's the name? It's going to give you 3-ethyl, right? 3-ethyl. Then carbon 2 and carbon 5 as methyl. 3-ethyl, 2,5-dimethyl. Dimethyl. What's the parent name now? 6 will be what? Hexane. Hexane. That's the answer. Option A says your 3-ethyl, 2,5-dimethylhexane. Correct. Option B, never. Option C, no. Option D, mba. What is the answer? Option what? A become the correct answer. Easy and direct. Please, I can't finish all the questions in this class, right? I'm going to stop here and go to my notes after the entire naming, so that you go and finish all the past questions that are in the notes under the naming of your what? Alkanes. But I beg you, please and please and please, the next class we're going to continue by looking at your zigzag representation. We are done with everything about your normal alkanes. The next class will be zigzag representation, isoalkanes, and your cycloalkanes. For the now, peace out. Hope you've enjoyed this class. Guess what? To follow up for more classes, just download the LearnLift app, whether on Play Store or App Store, and then follow up your classes. You must do extremely well. I'll see you in class. Bye-bye.